So welcome everybody who is joining us on YouTube. This is April 21st, and we are studying pre-calculus. So we're at the end of our triangle trigonometry unit. So the past week we spent sort of building up SOHCAHTOA and understanding how to find the lengths and angle measures for different triangles. And today we're going to do something a little bit more abstract where we start to build up some identities. So the first one is the sum and difference identities that you see in front of you here. And then after that, we're going to build up how we do equations of rotation, and that will lead us into some properties of animation. So what we're going to see is, how do we make things move on a screen, and what are the mathematics behind those things? And then we're going to actually go into Desmos, and we're going to create our own graphs that rotate and move. And so we'll be essentially sort of programming the Desmos graphing calculator to make a little animation for us as we go along, which I think is pretty neat. Okay, so in order to get to that point, I like this activity. It's a nice warm-up. And so what we're going to do is we're going to have a diagram that looks something like this. And as we go through, what we're going to want is to know is, what are all the different side lengths in this picture? So I'm giving you some information. I'm giving you that this bold line here, the length of that side is 1, okay? And what I know is that this angle right here I'm going to call A, and this angle right here I'm going to call B. Now, I don't know what their measures are. I don't know the measure of angle A. I don't know the measure of angle B. So we're just going to leave them as A's and B's as we go throughout. But using trigonometry, what we can do is actually figure out, hey, what are the lengths of the sides of this triangle and this triangle down here. So the general path that we're going to take is we're going to find the lengths of this triangle in the middle, and then we're going to sort of move our way around the triangle like this, or the outer square. Okay, so we'll find these inner edges first, and then we'll move to the outer edges. Okay, so some things to remind us really quickly before we get too far. So we had a picture a little bit before that said, if I have a triangle and this hypotenuse is length r, we could use sine and cosine to find their other lengths. So for those of us who are here, do we remember? So Nick, Carrie, Jody, do you remember, like, if this is theta and this is r, how do I find this base and how do I find the height?
Well, if you take like cosine of theta, that would give you the opposite over r.
Okay, so cosine of theta it would be not opposite but adjacent, right?
Oh yeah.
So if this is A, right? Yeah, so you would get this is r cosine theta. And so this comes from, right, what we developed, right, SOHCAHTOA. Right, so we're using this piece right here, right? Cosine is adjacent over hypotenuse, and just rearranging this gives me that we get r cosine theta is equal to A. Right, so that's exactly right. So this one down here on the bottom, this length will be r cosine of theta, and then what's our height? Right. So our sine theta is our opposite side divided by r. So if I rearrange that, right, we're going to get r sine theta is our opposite side. Okay. So as we go through, what I want everybody to keep in mind is we are, troubles with our virtual whiteboard here. What I want everybody to keep in mind is we're going to use this diagram a lot. Okay, so we're always going to be coming back to this thing right here, right? Whenever I have a triangle, that base, if I know the hypotenuse, the base is going to be r cosine of theta, and the height is going to be r sine theta. Okay, so we're going to use this a lot through our picture. Okay. All right, so coming back to this, can we use that information to determine some of these side lengths? So if my hypotenuse here is 1, what's the length of the base of this triangle? Okay, so I have this triangle, the hypotenuse is 1, and we said that this base right here is going to be r cosine of my angle. Okay, so as we go through this right here, this is going to be r times cosine of a. Okay, and then the height of my inside triangle, this side length over here, this is going to be r times sine of a. Right? So as we move through, we'll be able to determine, our different side lengths. Okay, so what I want to do now is I want you all to think about this down here, and what would be the length of this? Okay. So to backtrack real quick here. So when I said r cosine a, right? So our r in this case is 1, right? So these are just going to be cosine a and sine a. Right, so what is the base? What is the bottom of this rectangle? How long is that going to be? Any ideas?
Is it going to be cosine A over cosine B?
Let me see something here. I want to be able to change these.
Oh wait, no,
Okay.
It's not.
So we want to go down here, right? So we're going to check out this bottom. So you said, Nick, you said cosine A over cosine B?
No, wait. I think so.
Okay, so if we set this up, right? So in any triangle, right, we're gonna have whatever the hypotenuse is, right? So whatever this is, we're gonna take this number and we're gonna multiply by the cosine of this angle. Okay, so whatever this length is here, we're gonna call it r, right? So I'm gonna take whatever this number is here, I'm gonna multiply by the cosine of the angle to get that side length.
So it's cosine A times cosine B?
That's right, yeah. So this one down here on the bottom, this is going to be cosine of A times cosine of B. Okay, so what's the height going to be then?
Cosine A times sine B?
Yeah, so we're going to do the same idea, right? So it's going to be r sine of B, right? So this would be over here, we're going to get cosine of A, right? So that cosine of A comes from here, and then we're going to multiply that by sine of B. Okay, so as we're going through, we're able to determine our side lengths, right? So far so good. Remember, our original goal was to figure out all the side lengths. Okay, so let's go back through and let's see what else we need. We can move up here now. So we'll see if we can come up here and figure out sort of what these side lengths are. Right now, what I have from earlier is we already figured out that this length was sine A, right? So I have this triangle up here in the upper right. But what I don't have now is an angle. Okay, so I know that this angle was B and this angle was A. So in this triangle right here, I had an angle A. And in this triangle right here, I had an angle B. But if I come up here in the top right in this triangle, I don't have any of the angle measures. So this is a problem. I need to go through and see if I can figure out what these angles are going to be. All right, so as we go around this triangle, let's see if we can fill in some angles. Okay, so specifically, I'm going to try and fill in these two spots, these two angles that I circled in blue first. So remember, we don't have numbers here, but what do we know about the angle sum of triangles? We know that they should add up to 180. So I should be able to figure out what goes up here, right? So if this angle was X, what I should have is that A plus 90 plus X is equal to 180. Okay, so what I'm doing is I'm going through and I'm saying A plus 90 plus X, all those should add up to 180. Okay, so if I solve this equation here, what I would get is I would get A plus X subtracting 90 from both sides gives me 90. And so that angle has to be 90 minus A. Okay, so I'm going to go ahead and put that up here in the top right. Okay, so we'll swap out our angle measure here, right? So we know that this is 90 minus A. And similarly, what should we see down below?
90 minus B.
Yeah, this one should be 90 minus B, right? So pretty much the same computation down here. And so what we should get is that this angle down here is 90 minus B. So let's go through here, and we still don't have an angle in that upper triangle, but let's see if we can figure out what this angle is right here. All right, so I'll erase our work from over here. So can we use this information now to get that angle? So here's a question. If I take this angle plus this angle plus this angle, and I add them up, what do I get?
180.
How do you know that, Nick?
Because a line always has 180 degrees.
Yeah, right. So it's a straight line, right? So that's going to be 180 degrees to go all the way around. So what I get is I get X plus 90 plus 90 minus B is equal to 180. Okay. So what's this 90 plus 90 in the middle is 180, right? So I get X plus 180 minus B is equal to 180. And so I subtract 180 from both sides, so I get X minus B is equal to 0. So then in this case, X has to be equal to B. Okay, so that's pretty cool. As we go through, this angle down here is the same as this angle up here. So that's pretty neat. So I can do this. I'll swap this out, and I don't need a formula in there, right? So this is just, this angle is just B. All right, so going back to the early bits, right? So I'm gonna go back to my red color now for my edges. So we figured out what our edge lengths were if we had an angle, we had a side length, and now what we do is I have the same kind of thing up here, right? Now I have an angle and I have the hypotenuse, so I should be able to go ahead and figure out what these two sides are here. So I'll give you all a minute. Think about this. What would the values that go into those spots have to be? So Jody, Kara, are you both hanging in there? I haven't heard from you in a while. Still holding it together? Jody's good. All right, all right. All right, so what would go up here in the upper right? What would go over here? Any ideas? Right, so if I sort of pull that, if I pull that triangle out of there, right, I have a triangle that looks like this, right? So this is B, and then this top is sine of A. And so what we're seeing, right? So let's see, like, right? So basically, your triangle would look something like this, right? So there's B sine A, and then just so we can see it, I just pulled it out of there, and then we're gonna spin it a little bit, right? So if we want to look at it this way, so now this triangle looks very similar to what we had before. Okay, and so along the bottom there, we should get our cosine of B, right? So this should be here, we should have sine of A times cosine of B. And then up at the top, that's going to be our sine, right? So at the top here, we should have sine A, sine B. Right, so, all right, we almost have all the sides, right? So what we need is we need two more over here, right? Just two more. And let's see if we can fill in all of our other information, right? So in the top of this triangle, what we have, this angle right here should be 90 minus B, right? So that's the same that we did before. And then if I add everything up, right, again, if I add all these together, what I should get is that if I add these three angles up, I'm going to get a new angle over here. And so very similar to the process that we did before, the angle that's going to go over here is going to be A plus B. Okay. So now what we're going to do is we have this triangle that's up at the top, right? So I have an angle, A plus B right here that I'm going to use. And I have a hypotenuse, which is 1. And so we're going to find the side lengths. Okay, so the side that's adjacent to the angle, right? That's how we use cosine, right? So this is going to be cosine of a plus b. And this side is going to be sine of a plus b. Right, so that's the opposite. Okay, so lots of information here. Okay, so lots of information. So we're going to see that if we can view this in a way that we wanted to. Oops, I group my angles in there. All right, so we have all this information. And remember that up at the start, what we were doing is we're calling these sum and difference identities for sine and cosine. So when we come down here for our formulas, what we're going to want is we want to know what is sine of a plus b and what is cosine of a plus b. So when we look at these two things, when we get to calculus, one of the things that we're going to be particularly interested in is what are these identities? So how do I know if I take the sum of two angles, how can I break that down into something that is more meaningful to me, right? So we can go through an example of this afterwards. Let's just see if we can get the identities out of here first. Okay, so going back up, all right, so we have these things that we want, sine and cosine of a plus b. And one of the interesting things here is we have a rectangle. Okay, so I know that this side length over here, right, is sine of a plus b. And in order to get that side length, it has to be the same as the two sides over here, right? So it has to be the same as this side plus this side, right? So what I'm going to do is I'm going to end up adding, right? So let's make that a plus sign, right? So in order to get sine of a plus b, I'm going to end up adding these two other side lengths together, right? So what I get is this is sine a cosine of b plus cosine a sine b. Okay, so we'll have this identity in here, which is nice, right? So this is a new identity that we have for trig functions. And similarly, what I can do for cosine of a plus b, what we're interested in is, I'm interested in this side length right here, right? So I want to know how long is this? And if I want that side length, what I can do is I can take the bottom side over here, and then I can take away this part up here, right? So if I take the whole bottom and I subtract that little bit on the right, what's going to be left over is cosine of a plus b. So what I get down here is I get cosine a cosine b minus sine of a sine of b. Okay, so this is what we've done here is we've developed some identities for sine and cosine. Okay, so as I said, this is the warm up, right, to get us in the right brain space for what we're doing here, right? So what we did is we have some arbitrary angles, and what we wanted to do is we wanted to build up sort of an understanding of what different side lengths were depending on angles. And so we actually derived these two identities that we can now keep and, you know, keep in our notes and all that. And so we have these for the future. But what we want to do now, well, let me pause here. Let me not get ahead of myself. Do we have any questions about this? This is a pretty abstract thing that we went through, so I'll kick it over to you all and see.
No, that makes sense, I think.
Okay. All right, so we have all of our information in here. We've built this up and then we've actually proved, right? We proved that these identities hold, right? So without a doubt, right, this would be our one instance of a mathematical proof, right? We've proved these identities and we did it through this proof by picture, right? So we worked through this diagram, and no matter what A and B are, these identities should hold for us. Okay, so what we're going to do now is we're going to do something very similar to help us figure out what the equations for rotation are. Right, so we're going to go ahead and I'm going to bring up a graph. So this one is posted on Play-Doh. Okay. And so I'll go ahead and share it here. Okay. Can we all do that switch over for you?
Yep.
All right, so you're able to see this. All right, so what we're going to do is I want you to imagine sort of taking a triangle here. So you have this triangle in the plane, right? And so we can figure out what they are. And what we're going to do is we're going to rotate this around the origin by some angle that we're calling A, right? So what we can do is we can take this triangle, we can rotate it around the origin by some amount, right? So if I go all the way around by 2 pi, we'll get back to where we started, right? So in effect, what I'm doing is I'm taking this one point, right? I'm taking one point and then I'm rotating it around the origin, right? So if I can do this for one point, then I should be able to do it for a bunch of points. Right? So if I do them one at a time, and so what we're going to see, at least in your graphs, is we're going to do our rotations one at a time, and we're going to rotate these points around. But if I rotate by an angle A, if I started at a point XY, I need to figure out what the new coordinates are going to be, right? So what is the coordinate of this point, right? So if I rotate around the origin by some angle, I need to be able to tell the computer where should I put that point on the screen. And so that's what we're going to try and build up here today. And so it turns out that it's all based on these triangles. So if I can figure out how do I rotate these triangles, we are going to be able to determine the coordinates of the points, right? So in our notes, right, so you'll see that we don't have the dynamic picture in the diagram, but we have something that looks like this, right? So if you are in section 7.5 in the notes, you should see something that looks like this. Okay? And so what we're going to do is we're going to go through, right? So we're going to go through our picture and we're going to try and figure out what the coordinates of this point are, right? So remember, right now I could, if I wanted to know these coordinates, right, what I could do is I could read off the value along the x-axis, okay? So I could read off a value along the x-axis. I want to know what this distance is, and then I would want to know what the height, right? I would want to know what the height of this is. Okay, so as we go through, we're going to use some triangle trigonometry to figure out, two specific side lengths. If I can figure out what this side length is here, right, so from 0, 0 to where this vertical line drops down, that's going to be the x coordinate of my point. So whatever formula that I get from that, that's going to be the equation that I use for my x coordinates. And then I'm going to try and figure out the height. And so whatever the height is of this, that's going to be my y coordinate. And whatever equation that comes out of that, that's going to be the equation that I use for my height. Okay. So so let's see if we can figure that out. Right. So we have this information in here, and what we're going to do, I'm going to sort of flash this on the screen right now so that we can have a visual for when we go over and start writing on our picture. Okay, so so our second triangles are going to be in here, right? So there's really 4 triangles that we're going to be dealing with to try to find side lengths. So we're going to see if we can put all that together. All right, so our first triangles are going to be here. They're sort of given to us, and then we're going to have these other triangles that we want to sort of reference as well. Okay, so let's jump over to our blackboard and see if we can put all this together. Okay, so down here we have our picture, and I want to sort of mark up some things that we know, right? So some things that we know so far. All right. So the first thing, as I pick off some information, as we saw in the Desmos screen, this angle right here, right? So we're rotating up by an angle theta. Okay, so we're going to call this angle right here theta. We took our triangle, we rotated it up by theta. So we know that. And if I come over here with this triangle, I know that my x coordinate, we're going to call it x. So this whole length, the length of this base down here, the whole length is x, and then this height right here is y. Right, so that's what we're working with so far. So we're going to go through and see if we can figure out some other pieces of information. Okay, so any ideas out there on what we could do? I guess I didn't write these in, but these should be right angles. I'll put this in here as well. So any ideas on how we can fill out this this picture?
Well, if the rotated triangle is the same one, right?
Yep.
So then the top line, one of the triangle, we could fill in a y and an x. Those are just going to move.
Just like this, right?
Yeah.
Yeah, so those lengths are going to be the same. So as we move up, same triangle, right? We're rotating it up. So that's exactly right. That's going to be an x, and then the top side there is going to be a y. So a hint that I want to give everybody is I want you to be thinking about this blue triangle right here. Right, so as I go through and I look at this, I'm thinking about this blue triangle, right? So remember we flashed those 2 triangles in on the screen, and so these 2 triangles right here are going to be the ones that are particularly important for us.
Opposite the theta, that blue line, that's just going to be cosine theta x.
So this right here, right? So this blue side, we'll put it in red. You're saying that this is x cosine of theta?
Mm-hmm.
Okay, so that's close. Not quite right. So remember, what goes with the opposite sign? Is it
that's
sine or
sine.
cosine? Sine, right? Yeah, so that's not going to be cosine, but in there you want that to be sine, right? So this is going to be x times sine of theta.
And then the bottom one will be cosine.
Yeah, right. So from here all the way to here, this would be x cosine of theta, right? Okay. So what else do we know? So as I go through, we've sort of figured out the length of the size of this blue triangle, but we don't know any angles in this triangle up here. So can we do something similar to what we did before and figure out, hey, what these angles have to be? Okay, so this would be, right, this would be 90 minus theta, because this is a right angle. And then just like we saw earlier is that this is going to have to be theta again, right? So this angle down here and this angle up here are going to be the same. So now what are the side lengths in our green triangle?
So the top one would be y sine theta, the top of the rectangle.
Mm-hmm.
And then the side one would be y cosine theta.
This is y cosine theta. All right, so so as we are filling this out, we have almost all the information that we need. Right, so really what we wanted, right? So we want to know if I'm going to find the coordinates at this point, really what I want is I want to know, so let me back up here. If I'm going to, I want to know what this height is, right? So that's going to be my y coordinate, okay? And so I think that I could read that off the graph so far. But now what I also need is I need this base right here, right? So that's going to be my x coordinate. So I think to get my y coordinate, I can just add these two together. Right, so that'd be my y coordinate. But then how do I get my x coordinate? Can we figure out what this length is right here?
Is it x cosine theta minus y sine theta?
That's right. Yeah. Right. So this is going to be so as we draw in here, right? So this side length down here would be x cosine theta minus y sine theta, and then this side right here, right, that height is going to be x sine of theta plus y cosine of theta. Yeah, so if I want to find my new coordinates, so I'm going to take a point in the plane, I'm going to call it xy, and if I want to rotate it around the origin by theta degrees, the new coordinates are going to be up here, right? So the new coordinate up at the top, the y coordinate is going to be x sine theta plus y cosine theta, and the new x coordinate is going to be x cosine theta minus y sine theta. Right, so through this diagram, through triangle trigonometry, these two equations that we've developed right here are super, super important. Okay, so these two right here, we want to hold on to those ones. Right, so you saw me how I made that movable diagram in Desmos, and these two equations are going to be what's happening in the background, right? So this right here, really good. Okay, so let's jump back over to Desmos and see how this is working. Okay, so same diagram, right? So we have this thing sort of rotating around like this. And the coordinate equations that we want are these ones right here. Okay, so the way that I created my triangles, the way that I'm getting them to move, is I'm using these equations right here, right? So I use t instead of theta, But my new x coordinate that I get is going to be this x cosine theta minus y sine theta. And then my new y coordinate is x sine theta plus y cosine theta. So I guess the question for all of you is sort of, how does this work, right? How does this work inside of Desmos? How does this help me with my Desmos project? And so if you have a Desmos project up or something up right now, so what I'll do is sort of show us, I'll walk us through how we can develop these things. So just for ease, I'm gonna copy these over so we have some notes here, right? So this is our new x coordinate, right, was this one. And then I'm gonna put a little note here that says, hey, this was our new y coordinate. Right, so I have these in here. Just, we don't need to put sliders or anything. This is just a note so we can see things happening. Right, so what we're gonna do is we look at a graph. Say I look at a graph that looks like this. Y equals x squared. Right, so I have my parabola here. And so what I want to do is I want to take all of these points and I want to rotate them, right? So I want to get them to rotate around the axis by some angle. And so what I'm going to do is inside of my expression list over here, I'm going to go ahead and I'm going to replace, anytime I see an x, I'm going to go ahead and I'm going to replace that with this new y coordinate that I have going on, okay? So I'm going to take this and instead of y, I'm going to just copy and paste it. I have this new y coordinate going on over here. And then anytime I see an x, okay, so not the new x's that I just put in, but anytime I see an x, I'm going to replace that x with that expression for x. Okay, so now here what I'm going to do, I'm going to add a slider t. And I'm going to change this from 0 to 2 pi. And so what we can do now is we can get our graph to rotate around the axis. Okay, and so if I just wanted to continually rotate right here, right, you can see that, right, my graph is moving, and there's this center of rotation, right? So this point doesn't move, it's just sort of spinning, right? It's sort of spinning around that point right there. Right, so we are rotating around the origin right there. Okay, so this is just a quick example of how this might work. So one thing that I want to caution here for everybody is if you look at this equation as it stands right here, it looks pretty complicated, right? So you see there's a bunch of sines and cosines and y's and x's are all in there, and it's like, I don't know, I'm not sure what's going on. But we didn't start that way, right? That's not the way that we built this up. Okay, so where we started was we started with something that we understood. Right, we started with this, y equals x squared, and I didn't type the whole thing out. Right? I didn't type out that whole expression. What I did was I said, I know that my y's are going to be something that looks like this. My x's are going to be something that looks like this. So I went through and I just copy pasted them into the spots that they should go in. Right, so I copied this x and I just pasted it in here, and then I copied this y, and then I pasted it in here. And so just through some copy and pasting, I put it all together, right? So I think that this is a lot easier to do than trying to type this all out by itself, okay? So while we're here, I'll kick it over to you. Any questions about this so far?
Yeah, so I emailed you yesterday. I said I've been doing my Desmos on an iPad, Now, is there a way to copy paste like these equations on an iPad with Desmos?
So are you bringing it up in like the Safari browser?
No, I'm using the app.
Okay, so let's see if we can do it in the browser. So you saw that I was doing this. So so if I type this in, so let me share my iPad, and I'll try to work on my iPad, and maybe that will help you out. Maybe we can figure it out together. Okay, so now what you see, the Desmos window that you see now here, this is me on my iPad. Okay, so I had this x cosine t plus minus y sine t. Right, so I have this equation. So the question is, can I copy this? So I think so, right? So do you have a keyboard?
No, not with the iPad.
Okay, so I have a I have a little keypad that I work. I don't know if you can see here.
Yeah.
I have a keyboard. So let's see if I can do it without my keyboard. Hmm. So yeah, I think so. So I don't know, Carrie, Joe, do either of you have an iPad that you're working on, or you're all working on desktop,
Working on my laptop.
laptop? Um, I don't know. It seems to want to copy this thing down below. Yeah. When I like copy this, I don't know. It's not like reading it that well. So Nick, when you type everything in, do you type it in on this keypad down here?
Yeah. So I don't know right away. So so what I'll do is I'll play around with this a little bit. I don't know straight from the iPad if I can do it, but you could. I mean, it's certainly going to be more challenging to type them in line by line. Yeah.
It's doable, but remember, when you get this thing to move, you're not going to have to replace every single line that you want. Okay, so so I don't know right away, but I'll make a note to do some investigating and see if, how do I like copy this line from an iPad. So I know that, did this work for you where you could duplicate it?
Yeah, I have been able to do that, but I don't know if there's a way to duplicate into another equation that's already built up.
Right. Yeah, I want to like copy this. Yeah, because usually you just kind of hold, and then it should tell you to bring up this, right?
Yeah.
But it doesn't seem to like read it that well, right? You can see like where it's highlighting.
Mm-hmm.
That doesn't seem to work very well. So I don't know. Unfortunately, I'm not sure now. But I'll keep exploring that for you.
All right.
But so I do have some other things I want to show you all. So I'm going to jump back over to the browser and work on my computer here, right? So we still have our image rotating. So let's go ahead and let's make a quick image. So I think I told Carrie that let's make a triangle. So I'll go ahead and make a triangle. So I'll take this line y equals x, and then I'll cut it off here. And then let's do something else where we have a y equals 2, and then we want to have this same restriction here, and then we'll do an x equals 4, and then we want to have we'll want to cut off our y's. Okay, so we've got this triangle here. We'll keep it a green triangle, and what we're going to do is we're going to take this triangle and we'll rotate it around the origin, right? We'll see sort of how we can do that. Yeah, so this seems good, and so we'll do something like this so we can see it a little bit better. All right, so I have these new equations right here, and so when I do this, I want to make sure that inside of my restrictions, right? So a lot of your pictures are probably going to look something like this, where you have your equation, it's either y equals something or x equals something, and then you're going to have a restriction, right? Because you cut off, right? You told Desmos, hey, I don't want to see the whole line. I only want to see it in a particular range. So when you go through and you make these substitutions, you're also going to have to substitute out this x or y or whatever you put in here, right? So anything that you have in your restriction, you're going to have to sub that out as well, right? So when I go through with my x's, I'm going to replace not only this x right here, but I'm also going to replace this x inside here, right? And so for me, I like to go one line at a time. And so I'm replacing, right? I replaced my y, I replaced my x, and I replaced my x. Okay. So I'm gonna replace my y, and then I'm gonna go ahead. I'm gonna replace my x, and then I still have my x, and then I'll copy this. I'm gonna go ahead and replace my y. Right. So we'll add our slider t here, which is our angle. And so again, I liked it to go from 0 to 2 pi. And so we can make it rotate in one direction. All right, so this is our triangle now, and it is rotating around the origin, right? You can see where I set my sliders here, I just have it going straight in one direction. And then since I replaced it from 0 to 2 pi, I know that's one full rotation, right? So it'll go around one full time, and then it's going to start repeating on that particular interval, right? So this, we have our animation now, our triangle rotating around. But some of the stuff that we saw was, sometimes we don't want it to rotate in a full circle. Sometimes we do, but sometimes we just want things to sort of move back and forth, right? You want them to just like, maybe you have a hand, right, like this, and then somebody's waving, hi, right? So how would I get, right? So if I had a picture of a hand and then I just had it going back and forth like this, right? How would I get something to sort of just bounce back and forth? And so what you can do is you can actually mess with the sliders, right? So if I just wanted this triangle to sort of bounce back and forth, maybe I wanted it to go from here, and then I wanted it to go to here or something, right? So like this, right? So it seems like 5.18, right? So I have this value 5.18 would get me to here. And then, if I go all the way out to here, right, that would be 5.5. So I can go in and I can restrict where I want my slider to start and stop. So I think we said it was 5.18 to 5.5. And so if we try this, right, so what we'll see is, it's going to go through this and then it's going to reset, right? So just like we had it before, it's going to go through and it's going to jump just like that. So this is because of my properties right here. I have it repeating. I have it going in one direction, but I can have it bounce back and forth, right? So I can adjust my speed in Desmos here, right? So if we have a 5x, so you can see if I wanted something to just bounce back and forth, right? So in my animation now, right, over here on the right side of the screen, I have a triangle, right? That's just sort of bouncing back and forth. But over here on the left, we sort of have our code that we've written, right? So we've now programmed the graphing calculator to do this animation. Okay, so we could get this, and then lots of other things. So far so good with this. Does this seem reasonable? So Carrie, Jody, how are the two of you doing here? So Carrie, I know you're a little bit worried about this, but notice that like the first thing that I did is I just created a picture, right? So I didn't make it move. The motion happened all in a secondary step, right? So I just copy and pasted my equations of rotation that we did into the places that I wanted things to move. Right, so step one is sort of make your picture, and then step two is make it move.
So when is this due? Is it the end of this week or the end of next week?
The end of next week, right? So this week I think is a good time to work on it. So we're just hitting triangle trigonometry right this week, and so we'll start polynomials on Thursday. But we have some time, right? So you're going to have some time this weekend, right, to think about polynomial work and work on your Desmos project. So the polynomial homework won't be due until the next week because we'll spend some time on it next week as well. Right, so I think it's not due until the end of the semester if you need that time, but my advice is like we're sort of in a spot in the semester where we're in between chapters. So this could be a good time where you have maybe less pre-calculus stuff to do or less web work to do, and you could spend more time on this. So that would be my advice. Okay,
does the next web work open up on Thursday?
That's right. So it's gonna open up this Thursday when we start polynomials, and then it will be due the following Sunday. So you'll have about 10 days to do it. All right. So one last thing that I want to show everybody is sort of what we did down here is we had our picture rotating around this 1.00. And it's probably true that you aren't necessarily going to want your image to rotate around 0, 0. You might have another place that you want it to rotate around. Okay, so for instance, I may want my graph. I may want to take my triangle and I might want to spin it around a point that's sort of inside. So instead of having it sort of rotate around like this, could I just sort of get the triangle to stay where it is on the screen and then just sort of spin around its center or something like that? So what I'll do is say, like, if I pick a point, if I wanted to spin around, say, this point right here, could I make that happen, right? So could I make the triangle spin around that point rather than the center? Okay, and so the answer to this is we can. So I have another example of this up on YouTube as well, but I'll go through it here just really quickly live so you can see that. So if you're not rotating around the origin, what we're going to do is we're going to shift all of our coordinates here. Okay, so we're going to go ahead and shift our x's and our y's by this amount, by 3.5 and by 2.5. So we're going to take our x coordinate here and we're going to shift it by 3.5. We're going to shift our y coordinate by 2.5, and then we're also going to shift our outside by 3.5, right? So for our x, what we're going to do is we're going to replace all our x's. We're going to shift them over and then add our value here. We're going to do the same thing down here, right? So instead of x, I'm going to do x minus 3.5. I'm going to put this value in here. For my y, I'm going to do y minus 2.5. I'm going to do plus 2.5. All right. So if we recall, right, our equations over here when we initially did these were y equals x, and then x was between 2 and 4, and then we had y equals 2, and x was between 2 and 4, and then we had x equals 4, and then y was between 2 and 4, right? So these were our original ones. So now if I wanted to instead rotate around this point, I would go through the same process that I had before, except I'm going to use these new equations of rotation. Okay, so I'm going to replace all my x's with this here. Right, so I'll go through, swap out all my x's here, and then I'm going to swap out all my y's. Okay, and so when I hit play here, right, so if we make this go from 0 to 2 pi, what we should see is that this triangle will just start spinning around that point right there. Okay, so we can adjust our animation properties to see it if we want, and then if we wanted to just get it to rotate around a particular point, I can get something that looks like this. And so we'll go ahead and effectively what this amounts to is just sort of shifting our center of rotation over to where we wanted it to be. So it was 0, 0. That was sort of the simplest version of our equations. And now what we have is we're rotating around this point. Okay? And so same tricks apply, right? So if I just wanted this to bounce back and forth, right? So I could restrict my range over here or something, right? So I could do this and then get my animation to bounce back and forth. Right, and now we'll speed it up, right? So if I just wanted, my triangle to bounce back and forth like that, then we're able to do that. Okay. And so now, right, if I turn off all of my stuff, right, what I have is I have this animation, right? I have a little thing that I've created that moves and does stuff. And so here's all of the computer code, right? So the graphing calculator code that's here on the left-hand side. And so hopefully this gives you some insight into, if you're watching something on TV, right, and they do some graphics, right, so computer graphics or video game graphics or something, right, like how do they get things to move, right? How do I see these things moving on the screen? Well, there's lots of mathematics that goes on in the background, right? So here's an insight, right? So if we open up the expression list, here's our code, right? That's running over here on the sidebar, and on the right-hand side, what I get is my animation that I wanted. And so all of your goals are to create an image and then walk through this process, right, where we develop these equations of rotation and then create your own animation. So to me, I think this is something that's pretty cool, right? So we spend a lot of time on computers every day and screens every day. And this gives you some insight into, how are they working? How do the graphics work in the background? And how we can just use triangle trigonometry to actually make and create this piece of art or this animation that we have going on here.
So if you're like subtracting your say x coordinate in the original equation, when you plug in the new thing, are you gonna have to like put parentheses around it so it's subtracting the whole thing?
Correct. Yeah. So if it was subtracted, right? So if this was if we had if I had like a y equals negative x, this negative would have to go with everything, right? So if I wanted to rotate it around, my new x coordinate, what I would need here is I would have to put it in parentheses, so it's subtracting the entire x coordinate.
Mm-hmm. Okay.
If that makes sense here, right?
Yeah, same thing like if we had to multiply or whatever, we'd have to multiply it by the whole thing.
That's right. Yep. So if you had a multiplication in there or anything, you would do the same, right? So you can see like with this line segment here, we're getting it to bounce back and forth, and I needed to put that, this negative right here had to go with the entire expression. So exactly as you said, if it's multiplication, if it's a 7 or 10 or whatever, you'd have to put in parentheses. Okay. Yeah, that is important to know. So far, so good, Nick?
Yep.
So, yeah, I mean, I'll continue to think about the iPad dilemma, if I can come up with a solution to that. Admittedly, it is going to be easier if you can get access to a desktop.
Okay.
So I think it will be easier just because you have the ability to use the mouse to slide and copy and paste. It tends to be easier to work in that environment. Yeah, Desmos graphs on mobile are, they're doable. You can do them, but distinctly easier on a desktop or a laptop.
Okay.
So, yeah, you can probably hear my daughter crying in the background. So I'm gonna call it here. 1 minute. We have 1 minute to go anyway. So, but yeah, anything that comes up with this, you can always ask me questions. The easiest thing to do is, sort of, if you have a question about your Desmos project, send it to me. It doesn't have to be finished, and say, hey, I don't know how to do whatever it is you want to do. Then I can look at all what you have down and then give you some feedback.
All right. Thank you.
You are welcome.
Have a great day.
I'll see you on Thursday.
Bye.